Okay, I want to discuss enthalpy, and I want to use this little guy as an analogy. So I actually made this as a prize for groups in my third year course, but anyway, let's just say that I bought this. And let's say I bought this, it's a nice little golden gnome on a piece of carbon fiber. Let's say I bought this thing here on Amazon, and I paid, it's beautiful, I paid $25 for it. Okay, so what I would like to do is consider my account balance. I call it the account balance, say at the bank. Now, how much money do I have? But instead of it being at a bank, I'm going to call it at a credit union. Basically, another type of financial institution. Sorry, credit union. All right, and the reason I want to do that is, of course, because I want to use the letter U, because that's internal energy, and we'll make a nice little analogy. So what I'd like to do is I'd like to consider what the change in my credit union balance is going to be. And just like we did in the barber analogy, we had a transfer of money, okay? So we're going to have some transfer of money. But then we're going to also, in this example here, I'm going to say, well, when I buy something on, say, Amazon, I might pay fees, shipping fees for it, right? So the change in the balance is going to be Q minus the fees. Okay. Now you might wonder about the sign convention. So I'd like to show you. Okay, money out is going to be negative, and I'll show you. I think with by way of an example would be best here. The gnome, say it cost $25, and shipping was, say, $8, okay? So then we would say that the change in my balance, my credit union balance, is going to be equal to minus 25, because it was 25 out, okay? So the sign has to be negative, and then minus $8. Now I assigned the sign convention this way because fees, the word fee, the way it's defined, really already carries a negative sign. That is, if the bank calls you up and says, oh, hey, great, we gave you a fee, right? You're going to say, ah, brother, right? Because you know a fee applied to a fee put in is negative. So that's why I assigned the sign the way I did here. And I hope that you can see as we go through why that's the case. And there will in fact be a parallel with work and the change in volume that we'll talk about shortly. So say that's what happened. I would then find that my credit union balance had decreased by $33. Okay, but then sometime later, I forgot how much I paid for it. Now, I show one of my friends this beautiful gnome, and my friend says, she says, oh, how much was that? I want to buy one, right? And I say, I can't remember. I don't have the receipt. For some reason, I can't look it up online. And so what do? Well, I go to my credit union, I log in, and I see how much, I see the transaction. I see essentially the delta U equal to negative $33. Okay, and then I want to back calculate how much it cost. So I could do that. I could say, well, we know that Q then is going to be equal to delta U plus fees, right? That's just reworking this equation here. So it would be, in fact, minus $33 plus $8 equals $25. So I know, what do I know? I know how much the gnome it cost, how much it cost. Okay, and I've used here how much. I've underlined that because this is this term called enthalpy. Enthalpy. Okay, that's what it's going to be. And we, in fact, do use the letter H to define that. So now let's move into reality and thermodynamics and see how this analogy applies. So in most of our processes as engineers, the only work, or the work that we encounter most of the time, is so-called pressure volume, or PV work. Okay, so if I write the first law, delta U is equal to Q plus W, I could write in here, I could replace W with the work. with the work term, okay? That would be, say, if you burn some fuel, well, the fuel burns and it goes from, say, like gasoline goes from liquid to combusting and producing some gas as it expands, and that the gas expanding actually has to push the surrounding atmosphere back, and that actually does some work. So let me show you that here with another with a little sketch, right? So say this is our final size of our system, and then it was initially this size, right? Well, the change in volume is going to be V final minus V initial, isn't it? Well, V final is smaller than V initial, so this is negative, okay? It's negative, so that means that this P V type work, or P delta V, right, pressure pushing over volume, is going to be negative as well. So that means that if we write our first law now, first law, which was delta U equals Q plus W, that now becomes delta U equals, and this is for the conditions, see, PV work, and also you'll see that I did this for constant P, right? Most of the processes we do are exposed to the atmosphere, and so the pressure is just fixed at 1 atmosphere, okay? Those changes in our process don't affect the pressure of the surroundings, and so the pressure is maintained constant. So this is for constant pressure. We can then state that the change in the internal energy is going to be equal to Q minus, so we're adding this term that's already negative, so minus P delta V, right? So I hope you can see that perhaps that's somewhat similar to why I defined over here Q minus V's. So you can kind of think of it this way, if a reaction proceeds and gives off some heat, but also expands, it pays a fee to the surroundings to push back the atmosphere, okay? So this is, if you will, this is sort of like the thermodynamic fee that's paid. And similarly, if I wanted to then say, okay, if I just look at the heat term, okay, if I look at only the heat term, that heat transfer term, and I rewrite it, I could then say that Q, the heat, is equal to the change in the internal energy, delta U, plus P delta V. And we said that that is going to be something useful to us. It's how much we paid, essentially, right, for the gnome. And in this case, it's the heat accounting for this PV work. So it is the enthalpy, delta H. Okay, delta H is equal to, and I'll write it one more time here neatly, delta H is equal to delta U plus P delta V. And I'm going to give that a red box because it's an important equation, and I'll define that this is the change in enthalpy H. Change in enthalpy. Okay, thanks a lot.